Right, let's kick off then. So I'm Shailesh Patel, Head of AI for the HMRC Account. I also look after the AI Centre of Excellence, which supports the delivery groups across the estate. And we produce AI solutions, basically. What I'm going to do today is spend a bit of time talking about text analytics, predominantly. There's a lot of unstructured data out there. So everything from your pictures, your HTML text, pure text, speech to text, and so on, results in some kind of text type information that you can process in some clever way. So I like all the I like stats. So data production will be 44 times greater in 2020 than was in 2009. My favourite stat is in 2 days we create more data than the human race have created up to 2002, which I find an astounding statistic. Most of that data is unstructured. 70 to 90% of that data is unstructured. So we need an approach to get some insight into that data. There's lots of pattern-based approaches we can use, and that's what I'm going to go through today. Some of the understanding around clustering, classification, and what does semantic analytics mean, and so on and so on. And we're also accelerating these activities. So today, a lot of the processes carried out on unstructured data tends to be based on people writing scripts or going through that data manually. You know, somebody will get an email cache and they go through it looking for keywords or key phrases and so on. That doesn't necessarily need to be done today. Okay. What I was going to do was derive these equations from first principles. Is that okay with everybody? Yeah? It'll be fun for 20 minutes, or 22 minutes, 58 seconds. I'm obviously not going to do that. The idea here is all of the stuff I'm going to talk about today is underpinned by this type of mathematics. And in fact, if you know any of this, you'll recognise LSAs or latent Dirichlet allocations or principal component analysis, all fancy words for all this mathematics they use to underpin the capabilities that are available to you. It is fun to derive some of this stuff from first principle. When I started out on this stuff 7 or 8 years ago, that's what we did. Right, why do we need it? One of the first points is relevance. There's all that data out there, huge amounts of data. Do you really want to see it all? Not really. I want it to become more and more relevant so it's useful to me. You know, when you get your search results and so on based on search criteria associated with you, you want that information to be relevant. You also provide a lot of feedback in a way that's generally full of emotion, full of semantics and so on, grammar that you use to describe a product or a service. And that data needs to be processed. It's hard work processing that data. But again, we've got approaches to support that. We're all using AI assistants, whether it's Alexa, Cortana, Siri, etc. They're using a natural language processing capability that is getting better and better in terms of what it provides, in terms of understanding, and then generating a response back to you. Anybody saw Google I/O this year? You'll have seen Google Duplex. And it's a very narrow domain it worked on, but you could set it off on a task, it would go away and have interactions with human beings and responses and so on. It was quite clever. Worth having a look at if you haven't seen. Insights. There's an awful lot of insight associated with unstructured data, probably more insight than you've got within structured data. So again, using these approaches and text-based view, we can farm those insights. And then experiences. We want to improve the experiences the customer has. That could be with a service, with a product, with recommendations, and so on. How does it work? So this is a very typical pipeline, but it doesn't need to do this. This is just a definition of one that we tend to use. First thing we do is find a bunch of files that we want to take in. We extract the text out of it, do something with it, tidy it up, and that's where the normalization activity comes in. We remove punctuation, non-alphanumeric characters, and so on. Next thing we would generally want to do, and this is where we probably deviate when we want to do something else, is one of the approaches you can take is map it into a particular space. Vectorization is mapping it into a vector space, which is we associate a magnitude with it, which could be the frequency of a word or something like that. But something that we can measure numerically. Tokenization is the identification of characters into words or terms. It isn't that as straightforward as you think. You know, as Ron said this morning, all these things are pretty dull. So even saying, oh, well, that's a word, actually, is it really a word, a hyphenated word, and so on. There are all those nuances we need to consider as to tokenization. Stop word removal. So stop words tend to be words that we're not interested in. Text is full of lots of and the and of and so on. Those words are noise. We want to remove those kinds of items. We want to reduce the dimensionality. And what I mean by dimensionality is the characteristics associated with it, and that could be the number of words, the word frequency associated with it, and so on. We want to reduce that down because we want to work with something slightly smaller and it's easier to work with that. And then analysis of corpus. So you'll hear the term corpus used quite a lot in the text analytics space, and all we're referring to there is a body of text. And that body of text is made up of documents, and in that particular scenario, documents tend to be a block of text. It could be a sentence, it could be a paragraph, but something that is of interest to us. And then it's words and terms can be multiple words strung together. Okay? So we represent features or dimensions in a number of ways, and these are the two most popular ones. First one, bag of words. Whenever you work in the text analytics space, you'll hear this phrase, bag of words, and all that means is identify words and associate a frequency with them. That allows us to effectively put them in a bag, or in the technical terms, in a sparse array, effectively, and then measure against that. Okay? And the other way is when we want to consider the sequence of words. So when we want to consider the entirety of a sentence, we want to consider context associated with the sentence. So something that's grammatically structured is a set of sequences. Okay. Right, so these are some of the approaches which I'm going to go through in a little bit more detail. So you've got text classification, which effectively we've got a model and it knows what to look for because we've told it what good looks like. Topic modeling, we're trying to identify subject areas. Semantic analysis, try and get an understanding of the syntax of a sentence, the semantics of a sentence, the grammar of a sentence, what does it actually mean? You've got text summarization, something that's too long, didn't read, but I want it summarized, so it's a paragraph or a couple of paragraphs out of, say, 100 pages of text. Also, I've got text correlation, which brings information together in a way that shows you degrees of separation. That's incredibly useful in the text analytics space. Right, so first one, text classification. Probably the simplest one. How do we categorize based on what we refer to as a known prior? A known prior is something that we've already defined up front. We know what good looks like, and in the spam world is what are key phrases that denote spam, and what are key phrases that don't denote spam. We can use that to create some training data, create a trained model, and then predict on the back of that. We use it for recommender engines as well, whereby it analyzes the product information associated with a particular product that you've bought, and then finds recommendations based on that information. But a relatively easy model to implement, very fast, because they tend to use either a pre-trained model that you add to, so tend to apply, again, Bayesian statistics is an approach that they use in this space, referred to as an online model because it can be trained on the fly as we're moving through it. But a relatively straightforward approach which we can classify information through. Something a little bit more sophisticated, we'll try and cluster, and that is categorized based on similarity of information. So you might have keywords or phrases that are important to you that you want to categorize on. And again, there are two approaches that we tend to take in this space. So one of them is partitive clustering. And all we're trying to do here is basically say, and I'm going to use some of the maths terminology here, K-means clustering is an approach that we use in this space. Now K-means is all about, I will specify a number of clusters and then you go away and see if you can get close to that number. And all it does is when I say, oh, I think I've got 15 clusters in here, it will go away, find the centre of each one of those clusters, perform a mathematical calculation around it, and come up with those clusters based on that. And the other one is based on decision trees. So if we want to cluster together based on a set of rules, then we can use decision trees to work those clusters down. And there you can see a bunch of words that we put together based on a set of rules that we've implemented. Now, all of this stuff is based on finding similarities or finding closeness between those words. And the closeness is nicely defined in vector space. And in vector space, you tend to find that they implement all these mathematical models to support it. And I think the easiest one tends to be, to understand, tends to be the cosine distance. So this is probably taking you back to your O-level maths, GCSE maths, depending on your age. But if you look at the cosine distance, if you want to work out the distance between point A and point B, what is it? A squared equals B squared plus C squared minus 2BC cosine theta. That's not bad, is it? But what it's trying to do is, if that distance is small, it'll be a number that comes back. If that distance is small, then there's a relative closeness between those two phrases. And so it thinks that those are semantically linked. And if you've got enough information there, it will find that semantic closeness by measuring those distances. You also get edit distances. I mean, that one's a little bit easier to understand, where it's working out the differences between those words. You'll see woodman and woodland, you know, and the commonality there being wood. But the other words do make a difference, and again, it will perform a calculation around it. Euclidean distances, straight line between 2 points effectively. And we've also implemented, you know, the Jacquard distances based on set theory. So there's a bunch of approaches that we use to basically work out that similarity, work out those distances in order to create those clusters. So topic modelling is based on clustering effectively. But there is a slight difference. So if you ever go on any of these courses, they always ask you that question, what's the difference between topic modelling and clustering? The difference is, clustering, you'll only have an element that's identified associated with a single cluster. In topic modelling, what it does is associate multiple instances of a phrase or a word or a sentence with multiple clusters. So what we're trying to do there is, this picture is basically showing documents across the top and words down the bottom, and then the intensity of the cells is the frequency of those words. And we can use things like the latent Dirichlet allocations or latent semantic analysis to perform those calculations. And you saw how complex that maths is. 200 years old, by the way, a lot of that maths, but still applicable in terms of finding similarity. Now, that's quite hard to understand, but I've got a little animation here. It's got a bunch of words down the left-hand side and a bunch of documents across the top. And in a minute, it will start moving and it will show you how it actually performs that analysis based on LDAs in this particular scenario. And what you can see is now it's grouped together air, pollution, power, and environment. And that grouping could be, and you'll see the grouping in terms of the animation itself, in terms of the groups of clusters that are shown as a diagonal running across that grid. And you can see the groups in terms of the documents and the groups in terms of the words themselves. So you can see space, satellite, launch and booster kind of linked together, and you've got defence, nuclear and arms treaty. But applying, and you're probably thinking, yes, but I'd have to perform that LDA. No, you don't. A lot of the tools that are out there have an LDA capability when you're performing topic modelling. In fact, if you look at tools like SAS, they have a little widget you drag out that says topic modelling, and it will apply LSAs, in fact, in that particular scenario, to perform this type of activity. But it's quite powerful because it identifies subject areas that you could then subsequently use to train other models to say, go away and look at a corpus of text and find me these subjects based on this information, based on the terms that it's identified. Semantic analysis, what does it all mean? So a lot of the time, a lot of the text that we get back is a bunch of sentences. And we want to get an understanding of that sentence because that particular example in the bag of words space would be exactly the same. Same frequency of words, same set of words, but we know, looking at it, they're diagonally opposite. Those two sentences are different. We want to use different approaches to analyse that kind of text. So in that space, there's a number of approaches. First one based on grammatical structure. So it's got nouns, verbs, prepositions, etc. associated with it. Parsing it in that way, we can work out that those two sentences are actually different. They mean something different, and we would treat them differently, and we would score them differently. The problem with this type of approach is it tends to rely on grammatical correctness. If you haven't defined it grammatically correctly, it will have a hard time parsing it. It's also very language dependent as well. So it's in French, that phrase might not work appropriately unless you define the model appropriately and so on. So we want something that's language independent and something that doesn't rely on grammatical correctness. N-grams tend to support that problem space. So again, what we tend to do is break down the sentences in such a way that we can model them and then perform a statistical analysis against those broken down representations to work out the degree of separation between those sentences. And it allows us to then either infer or predict based on those sentences. But it's a more generalised way of extracting features and understanding the semantics associated with those sentences. And lastly, word embeddings, which I talked about earlier. If you map it into vector space, then actually we can start to find some of those similarities based on distances that we can calculate. Okay? There's a lot of pre-trained models out there that you may have heard of, word2vec, GLUD, LSAs, and so on. Right. Sentiment analytics. So this is all about opinion mining. So when you put a product review back against a product or a service, you tend to put a lot of meaning into it, expression into it. You might use sarcasm, you might use exaggeration, and so on. We want to be able to model it against that and come back with something that tells us whether it's a positive statement, whether it's a negative statement, whether it's a neutral statement, and so on. There's a number of approaches you can use in that space. So I've given you an example there. I love the fact that this product didn't work properly. Now, in the first approach, that will probably come back and say, use the word loved, so do you know what, I'm going to say that that sentence is a very positive statement, but we know it isn't. Actually, I'm using sarcasm there. So in the knowledge space, we tend to use effect words, which is a list of words that we deem appropriate from a positivity or a negativity point of view. And then we just look for those words based on the structure of the sentence. And if we get an appropriate score against that particular sentence, then we'll say if it's positive or negative. Great in supervised trained models, but probably not good when we're exaggerating or we're using any kind of language modifiers in that space. So we've got the statistical approach as well, which again utilises semantic analysis to go back and actually look at that sentence, and based on the use of the words and based on lots of sentences that we've collected in this space, it will perform that analysis and come back and say, well, actually, there's a sarcastic element associated with it, and it's really a negative statement. And finally, text summarization. So, talked about it earlier, there's approaches that we can use in terms of getting huge bodies of text and summarizing them. I was speaking to somebody earlier who works in the medical industry, basically says a lot of doctors, when they have to hand over records for somebody to another doctor, have to summarize those records. Actually, something like this could go, and they do those by hand. Now, something like this could go away and perform that first pass at text summarization in this space, which is break it down into something a little bit more concise. Two approaches in this space. First one is extractive. So it will identify topics that it thinks are important in that particular body of text. It will score those topics, and then using a trained model will basically work against that body of text in order to extract sentences that it can subsequently string together, that it thinks are appropriate as a summary against that particular body of text. And it can create that summary. It's great, but it's based on just extraction of text, effectively. Okay. Which is, I think, okay, but not really, it doesn't really summarize in a way. So you tend to find that it's good for bodies of text where they're well defined and we can work through and summarize based on the exact text that's there. But actually, abstractive is a much better approach. Now, this is a research field at the moment, but they're using semantic analysis to actually extract the text and then rewrite the text for you. So turn it into something a little bit more meaningful, because in the same way that we, as human beings, would parse that information, we would tend to find that when we want to summarize that text, we want to rewrite it to make it more concise, easier to understand, remove words, add sentences, etc., etc. It's a field of research which is being used in certain areas, but incredibly useful for performing text summarization. So some of those approaches are a flavour of text analytics. There's lots of other approaches in this space, but there's no wrong or right answer. The thing that you've got to perform in this area is evaluate the approaches. We tend to find that we build a lot of competing models to see which one gives us the right output from from the text analytics activity. So analyze the output, evaluate the output, and then iterate. There's a lot of tuning that needs to happen. Even though a lot of these things tend to come out of the box, we tend to find that they don't always give you the right answer right from the word go. So iterate over these, use lots of models, try lots of different approaches. It could be everything from a decision tree to classification to clustering to using LSAs versus LDAs as an approach. It's still a mathematical approach, still all driven by maths, still statistically driven, all statistics. So you need somebody to validate that model for you once it's created and you want to generalize against an actual data set. So we tend to find that the conversations we're having with some of our customers is build a smaller contingent of mathematicians and AI specialists who can validate the models that you then use for general use out in your business or your organisation. And finally, enterprise AI. So how do we accelerate some of these activities? So I mentioned some of the tools that are out there, like Glove and so on. You can start from the ground up, building all of this stuff from using Python or R, or you can abstract and use some of the other tools that are out there that have already got these models that are built into them. Okay? It lets you accelerate the activities in terms of building these models. It lets you iterate over them quicker. It also allows you to industrialize them in a faster way. You can deliver them faster to your customer, to your end users. They tend to be, it's easier to evaluate the models and so on, and they tend to be easier to use at the end of the day. Okay? So hopefully that's given you a flavour of what we mean by text analytics, and it raises some questions and potentially takes some ideas forward in terms of how you can process that unstructured data that's out there. Okay. Any questions? Go on.
So the automation of abstractions, I would imagine they've got a fairly large training set that they could run that against too, because you've already got papers that have got abstracts. Have they tried that? So
a lot of the models that are already out there, like Glove, like the vectorization models that I talked about, like Glove and Word2Vec, are pre-trained models. We're finding that more and more models that appear in the text analytics space, because of the body of text that's out there, and generally it's language driven, body of text that's out there, like English, tends to be pre-trained, and so you can just utilize all the models out of the box. And you tend to get quite a high hit rate associated with those trained models. I'm also tending to find that a lot of models that are coming out today are also utilizing mechanisms like transfer learning. So if you don't know transfer learning, it's an approach in the learning space whereby you've got a pre-trained model and you introduce a smaller set of data, which is a nuance to your data set, effectively, which is the thing you're looking for, but you need that whole body of text in order to get to that position. A lot of the models that are being introduced are also giving you that capability. So utilize transfer learning with your data set, which could be language that you use in your domain. So in the HMRC space where I work, There's a lot of language that they use, a lot of terminology that they use in that space, and we could introduce that as a smaller subset of data against that trained data set, which makes it easier to add to that trained approach.